I'm a teacher from Ilm Online Academy. In today's video, the topic is reactions of the organic compounds. This is basically chapter number 19 of the ongoing series for the Cambridge Chemistry 0620, and in today's video we'll be having a look at the contents which are included in this chapter, which is reactions of the organic compounds. So in the previous one we talked about the introduction related to the organic chemistry and also organic compounds, but in today's lecture the contents which are included in this are, first of all, we'll talk about the characteristic reactions of different homologous series like alkanes, alkenes, we have alcohols, we have carboxylic acid homologous series. So we'll talk about the reactions of those series, and the next one we talk about different reactions related to these, and in the last we have the third one is carboxylic acids and also the esters. So we will talk about generally the reactions that are involving in the organic compounds. Without further ado, let's just begin, and let's first start with the alkanes, which is the first homologous series of the organic compounds. So if we talk about the chemistry of the alkanes, as we already know that alkanes are very unreactive compounds. First, we have alkanes, which is the first compounds. These alkanes are unreactive compounds, and why these are unreactive? Just because of the presence of only single bond. This is the first reason behind their unreactiveness. They are saturated compounds, right? They are not unsaturated, they are saturated and they have single bonds. So if we talk about the reactions of the alkanes, like as they are saturated, so they cannot take part in the addition reactions. They are unaffected by the acid and also by the alkalis. So however, they can take part in some reactions like substitution reactions, and particularly with the chlorine, that is a halogen. So if we talk about the first topic, which is alkanes as a fuel, we can use alkanes as a fuel. Like for example, we have the first member of the alkane family is, you know, that is methane. So if we use alkane as a fuel, then we have the simplest member of this compound, which is the methane. So methane, which is the major component of the natural gas that is used mostly for the cooking purposes in our stove. Natural gas is present in our stove, which is mostly used for the cooking purposes. We have some alkanes that are obtained from the frictional distillation of the petroleum, and one chemical property that all these alkanes have in common, that they burn very exothermically, means the reactions they are given by them exothermic. As most of the alkanes are used in the fuels, so when we burn the fuels, that means combustion will happen, and when combustion happen, we already know that combustion reactions are included in the exothermic reactions, because a lot of heat, a lot of energy is released in case of these reactions. So natural gas and various alkanes are very useful fuels. We can use them anywhere. We have this one, which is CNG. This is known as compressed natural gas. This has been used as an alternative fuel to the petrol, gasoline for the vehicles ranging from the long distance motor coaches, or also to the urban auto rickshaws. We can use them. Propane and butane, which are also the members of the alkane family, they burn with a very hot flames, and they are sold as the liquefied LPG, which is the liquefied petroleum gas, which is propane and butane. So propane and butane is sold like LPG, and methane is as a CNG. LPG is also used as a fuel in different automobiles. Okay, so most of the members, or you can say that the members that are present at the start of the alkane family, they are mostly gases, but if we talk about the higher members, they are liquids. So just because of these gases, we can easily compress them as a compressed natural gas or as a liquefied petroleum gas. So this is about the reaction or the combustion reaction of the alkanes, and now we'll talk about the reactions or equations that involve in the combustion of the alkane. So this is a short introduction related to the alkane family as a fuel. So now if we talk about the combustion one, or the combustion reactions which are involved. Combustion is this is a general term that is basically used for, you can say that, burning also. Combustion is related to the burning, and burning in the presence of oxygen. Oxygen is necessary, or oxygen is required, or you can say that air is required for the combustion. When a fuel is burned in the presence of air or oxygen, you call it as the combustion. There are two types of combustion. We have complete combustion and we have incomplete combustion. We already talked about this one in our previous chapters, complete and the incomplete. You can check my previous video related to this one in chapter number 17. So if we talk about the complete combustion, in complete combustion, a lot of oxygen is present, means in the presence of excess of oxygen, a fuel is burned, and the products that are produced in this, we have carbon dioxide and water vapors. These are released and they occur in the presence of excess of oxygen. Whenever there is excess of oxygen present, so the products by the burning of the fuel in the presence of oxygen are the carbon dioxide and water vapors. And if we talk about the incomplete combustion, the products are different. Why? Because incomplete combustion happens in the limited supply of oxygen. So whenever there is a limited supply of oxygen, like maybe in the engines of the car, in the car engine, if there is not much oxygen that is present there, so at that place incomplete combustion happens, and the products that are released are carbon monoxide gas, plus we have water vapors that are released, and also a carbon soot is released. In this case, these are the black carbon particles that act as an air pollutant in our environment. And incomplete combustion happen in the limited supply of oxygen. Whenever there is limited oxygen is present, then the incomplete combustion will occur. So alkanes burn readily when they burn in the good supply of air, means if we talk about the complete combustion, then carbon dioxide and water vapors are released. So the equation for this one would be, we have methane plus we have oxygen, and this reaction happens in a good supply of air. So the products released will be, we have carbon dioxide with carbon dioxide, we have water vapor that is released. So this is the word equation for the reaction or combustion reaction of alkane with the oxygen. Next, if I wrote here the symbol equation, the formula for the methane is CH4, and that happens in the oxygen O2. So after reaction, we have CO2 carbon dioxide plus water vapors that are released. And also write here as a gas because these are the vapors. So we will balance this equation like this. So this is the balanced equation for the combustion reaction of methane in the presence of air. And next we talk about another member like ethane. So we have, the reaction will be ethane plus oxygen, and then after reaction we have and the word equation will be, we have C2H8. This is the formula for the ethane, C6 or C8, it's C6, plus we have oxygen atoms that represent N, and then after reaction we have carbon dioxide plus water vapors that are released. So I will balance out this equation first. We have 4 here and 7 here, and then 2 will be like this. So this is the balanced equation for the combustion reaction of the alkanes, and we have ethane and methane. The same products are obtained whichever alkane is burned. So you can also do this reaction with the propane, with the butane, anyone, because the products will be the same. As long as there is a sufficient oxygen supply, the products are same. If there is a limited supply, then products will be changed, and in that case the product will be carbon monoxide, water vapors, and carbon soot that is released. So there is a key to balancing the symbol equations for those reactions is to balance the oxygen correctly. If you first balance the oxygen correctly, then there is no chance for the incorrect balanced equation if you want to try that. So we have excess natural gas, mainly the methane, that is sometimes flared off from the oil fields. This is just because of the burning. So if there is a limited supply of oxygen, then we have a poisonous gas that is released, and that poisonous gas is, as you know, that is carbon monoxide. So in the presence of a limited supply of oxygen, what will happen? We have carbon dioxide, that is the product of the incomplete combustion, and in that case, if methane reacts with a limited supply of oxygen, then we have carbon monoxide gas is released. This is the poisonous gas that formed whenever we have a limited supply of oxygen. So first you have to balance out the oxygen, and then you can easily do this one. So this one, as you can see here, this is the carbon monoxide. So this is the incomplete combustion. Carbon monoxide is toxic because interfere with the transport of the oxygen in our body by our red blood cells. Carbon monoxide has much more affinity as compared to the oxygen. So carbon monoxide attaches with our hemoglobin that is present in the red blood cells instead of the oxygen. So as this is a poisonous and toxic gas, that will also occur just because of this carbon monoxide. So incomplete combustion also produce a fine particles of carbon soot that I already told you. These particles have not been reacted to produce a carbon monoxide. It is the fine carbon particles that can glow yellow in the heat of flame. They give a candle flame or the safety flame of a Bunsen burner its characteristic yellow color. So whenever there is a carbon soot that is produced, you can easily check this by the color of the flame. So this is the characteristic of the carbon soot particles of the yellow flame. So the incomplete combustion of the fossil fuel is the major cause of the air pollution just because of the carbon soot, and the other one is the carbon monoxide gas that is released in this one. So these are the combustion reactions that happens in the alkanes. Next we talk about the substitution reactions of alkane. So now we have substitution reactions of the alkanes first of the homologous series. So substitution reactions are those reactions in which atom of a molecule is replaced by different atoms without changing the molecule's general structure. Like one reaction that alkane will take part is the substitution reaction, and that is mostly with the chlorines. They do these reactions with the chlorine. So in these reactions we have a hydrogen atom of alkane that is replaced by the chlorine. For example, we have the first member, which is the methane, and methane will react with the chlorine Cl2, which is a chlorine molecule. So after reaction, what we'll have, we have this chlorine atom will replace the hydrogen that is present in the methane. Like this is the structure of the methane molecule, and because chlorine is more reactive than the hydrogen which is present in this methane, so this chlorine will take this place or displace them, you can say that, or replace itself with the hydrogen in the methane. So now we have the structure, which is we have carbon and like this 3 hydrogen atoms with 1 chlorine. So this is known as chloromethane. 1 carbon is present and with the chlorine, so you call it as chloromethane. Plus we have HCl, hydrogen chloride, that is present there with the product. So this is how the substitution reactions happen. The more reactive one will replace hydrogen easily because hydrogen is not much reactive as compared to the chlorine. So a substituted chloroalkane is produced together with the hydrogen chloride gas. With this, the hydrogen chloride gas can be detected by using a litmus paper, blue litmus paper, which in turn changes into the red because hydrogen chloride has a low pH. It's an acid, so that's why it will change the litmus paper blue into the red. So this is the substitution reaction of the alkanes. How the substitution reaction happens: you can take any member of the alkane family instead of this methane. You can choose ethane, propane, butane, anyone, and the reaction will be just like that. We have one substituted product and other we have the hydrochloric acid, or you can say that the hydrogen chloride gas that is released with this one. Apart from these, we have one more, which is the photochemical reactions. These are also basically included in the substitution reactions. Like in case of photochemical means, as the name suggests, that in these reactions we have, in these photochemical reactions, activation energy is required to start the reaction, and that activation energy is provided by the light that comes from the sun. So basically you can say that this is the sunlight that is used here. So usually a particular wavelength that fall on the reactants, and then reactants will convert into the products. Like for example, we have methane, and methane will react with the chlorine gas Cl2 in the presence of the light. So whenever you provided a sunlight to this reaction, that is known as the photochemical reaction. This is also, you can say that, the subtype of the substitution reaction. But what happens, we provided the sunlight, which is the activation energy. Just because of that, chlorines are unreactive, so that's why you provide the sunlight as a activation energy to start the chemical reaction. So we have CH3Cl, which is the chloromethane, and plus we have hydrogen chloride that is produced in this. So methane and chlorine react in the presence of oxygen or as a source of ultraviolet light that we provided here. This is UV. You can also say that there is no reaction between the alkane and chlorine in the dark, so you have to provide it. The ultraviolet light provides the activation energy, and activation energy is that energy that is used to start a chemical reaction. So when we provide the energy, this chlorine that is present there will split, the bond will break, and then the atoms will react with the methane. So the overall result is the chlorine atom that replaces or substitute a hydrogen atom in the methane molecule to give a chloromethane. This is known as chloromethane because chlorine is present with the methane molecule as a substituted product, so you call it as a chloromethane. So this is how this reaction happens. You can do this with the ethane, propane, butane. You can use any member of this family to do this one. And also one more thing, this reaction will happen further also, and how, I will tell you. Now you have to take this product again in the reactant. Take this product in the reactant like CH3Cl, and now you again have to react it with the chlorine gas. So when it will react, it forms now CH2Cl2 plus we have hydrogen chloride. You can again use this product to remove the hydrogen atoms, and whenever you use this, what will happen? Now we have CHCl3 plus we have hydrochloric acid. So the reaction further continues whenever all the hydrogen atoms are used up. After that, one more reaction will happen, CHCl3 plus Cl2, and after that we have CCl4, which is carbon tetrachloride that is formed here. And this carbon tetrachloride, this is the first one is you can call it as dichloromethane because two chlorine are present. Next one is trichloromethane, and the last one is tetrachloromethane that are formed in this reaction. So these are the substitution reactions for the alkanes. You can add chlorine in the product till all the hydrogen that are present there are used up. So the substituted alkanes are good organic solvents. All these are the good organic solvents: carbon tetrachloride, dichloromethane, and also trichloromethane. The trichloromethane that is present here, this one is used as a dry cleaning agent. So this is mostly used as a dry cleaning agent in industries. So other alkanes also react in the similar way with the chlorine, as we have just do this with the with this one. So these are the substitution reactions that happens in the alkanes. So now we will talk about the alkenes. So first, the chemistry of the alkenes. Alkenes, as we already know, that these are the unsaturated hydrocarbons in which we have a double bond. So just because of the presence of that double bond, you call it as the unsaturated hydrocarbon, and they are more reactive as compared to the alkanes just because of the presence of the double bond that is present in it. Under suitable conditions, the molecules of the bromine, hydrogen, and water will add across the double bond that is present in this molecule. So you can say that alkenes undergo addition reactions, and the reactivity of the alkenes are also much more important for the synthesis of some organic molecules. So the most important source of alkene is from the catalytic cracking of the long chain alkanes from the petroleum products. So for that purpose, first we will talk about the catalytic cracking as a source of alkenes. Like we can get the alkenes from the catalytic cracking. Very few alkenes are found in the nature. So to obtain the alkenes, we break down the larger and less useful alkane molecules that are obtained from the fractional distillation of the petroleum. We will discuss this fractional distillation later in our chapter, and this breaking down of larger alkanes is known as the catalytic cracking. So what will happen in this? We have large alkene molecules that are passed over a mixture of aluminum and chromium oxides, and they are heated to about 550 degrees Celsius. And the example of this one will be, you have a long chain, you can say that we have a long chain alkane, that is C12H22. This is the alkane that we are using, and this we have a catalyst that is also used here. That's why we call it as catalytic. In this we use a mixture of aluminum and also chromium. Chromium and aluminum is used as a mixture in this one, and the oxides of aluminum and chromium are used mostly as a catalyst. So catalyst, you can say that catalyst is just for increase in the rate of the reaction. So whenever a long chain molecule of alkene is broken down, so we have then the alkenes. For example, we have C10H22 plus, after we have C2H4. So this is the ethene that is produced by the catalytic cracking of alkanes, and we have decane. So you can further break down this decane for the manufacturing of the alkenes. So larger alkanes are not very useful, while the smaller hydrocarbons are more useful in demand. So therefore you can use larger alkane molecules here in the catalytic cracking just for the production of the alkenes. So 500 degrees Celsius is the temperature that is required in this. And if we talk about further for the breakdown of this decane, that is C10H22, and when we heat them at a required temperature, that is 500 degrees Celsius, and catalyst is also added, which is the oxide of the aluminum and the chromium. So we have then octane, that is C8H18. With the octane you have alkene, that is ethene, C2H4, that is produced. So a longer chain alkanes can be used as a cracking to produce the alkenes. This is just one of the possible reactions. When decane is cracked, the molecules may not all break in the same place. The alkene fragment is not always the ethene, propene, but we have some other products that are also produced. Some hydrogen is also broken off from the long chain alkanes that are being cracked. So all the cracking reactions that we are doing here, an alkane with a shorter chain than the original and a shorter chain of alkene is released. Like, so these are the cracking reactions that they give us, they give the alkane with the shorter chains in the original, and a shorter chain alkene is given off whenever we do the cracking of the alkanes, and 2 or more alkenes and hydrogen is also released in this. All the products of the cracking are useful. The shorter chain alkanes can be blended with the gasoline fraction to enrich the petrol. So we have some also useful purposes through which you can use this one. Now I will tell you some important products that can be made from the ethene by the catalytic cracking. We have a flow sheet diagram through which you can easily assess the products that are produced from the ethane which is cracked. So these are the important products that can be made from the ethene that is produced by the catalytic cracking. As you can see here, all the products that are produced by the cracking, they are useful, and the shortest alkanes can be blended with the gasoline fraction for the petroleum or petroleum products. So we have, you can see here, these are the alkenes that are useful as a raw materials for making several important products that we can use in our industries, in our daily life. So we have some important uses for the ethene that are produced, while other alkenes are also useful. But in case of ethene, if it reacts with the steam, it produces ethanol. Ethanol is much more important alcohol that we are using because it is used widely in so many different industries for the preparation of the different things. And the next one, that is the polymerization. If polymerization reaction happens, that means monomers attached, a lot of molecules attached together, and then they form a polyethene. To form a, we can use it everywhere, like in the polythene bags that are used nowadays for the different purposes. And next, if it reacts with the chlorine, it forms a chloroethene, and after polymerization we have PVC, that is polyvinyl chloride, that is used in the for the making of the plastic pipes, which is used for water, for the sewage, for anything like that. So these are the products that are produced whenever the cracking of the ethene happen in the industries. So these are the important products, you should remember all these. Now we'll talk about the cracking reactions that happens in the laboratory. So the first one, as you can see here, the first picture that shows here the cracking of a long chain alkane in the laboratory. How you can do this? We can do this by using a paraffin oil. Basically, a medicinal paraffin oil or a paraffin oil is used for the cracking of alkane in our laboratory. The catalyst is heated strongly first and then the paraffin. So we have a paraffin vapors that passes over a catalyst. You can see here this delivery tube. This is just for the whenever you heat the catalyst that is present here, so the vapors passes over the catalyst that is kept hot, so the gases produced in the cracking reaction can be collected in the test tubes. You can see here the gas will pass through this delivery tube, and when they pass and when they comes into the water, we have a we put the test tube, or any cylinder can be put down in our water tank, or you can say that any container. So the gas is accumulated in that test tubes. The gases produced can then be tested to see if they are alkenes by using the bromine water test, which we done in our previous lecture. So for the safety, the delivery tube can be fitted with a safety valve or a Bunsen valve, you can say that, just to prevent cold water being drawn back into the hot apparatus. So this is just how the cracking reactions happens in our laboratory with the paraffin oil. You can use them. The second picture you can see here, this is the Bunsen valve or the safety valve that we are using here. So the use of a Bunsen or a safety valve just to prevent the suck back of the water and to prevent the cold water being drawn back into the hot apparatus. So this is just for the safety. We have a slit in the rubber tube that is present there. This is for the safety, and the delivery tube is attached to the left, and the glass rod is present on the right side of this one. So this is how the cracking reaction happens in our laboratory. Next, we talk about the combustion reactions of the alkenes. So alkenes are similar to the other hydrocarbons. When they burn, they give carbon dioxide and the water vapor as long as the air supply is sufficient. So the reaction for this one will be, we have the first one, which is the ethene. which has the formula C2H4, and when it reacts with the sufficient supply of the oxygen, then after the reaction the products that are produced here, we have carbon dioxide plus water vapors are generally released in this one. So this is the complete combustion reaction for the alkenes. The presence of carbon-carbon double bond in the alkene molecule makes these molecules much more reactive than the alkanes. So alkanes contain only carbon-carbon single bonds, so alkenes take part in the addition reactions also, in which we have two substances that react together to just form a single product. We will also talk about those addition reactions now. So these are the combustion reactions, and they burn just like other hydrocarbons, they are present there. So next we have, you can say that the addition reactions for the alkenes. So if we talk about the previous one, we do the addition reactions of alkanes also with the presence, or substitution reaction, sorry, not the addition reaction for the alkanes. But for the alkenes, they do, or they undergo substitution reactions and addition reactions because of the presence of the double bond. So alkenes can take part in the addition reactions. Other atom can also add them just because of the presence of the double bond that is present in them. So the difference in reactivity between the unsaturated alkenes and the saturated alkenes produces a simple test for the unsaturation, and that test is for the by the bromine water that we have also discussed in our chapter number 18. So this is the bromine water test that we can do for the unsaturation, if it is present in them or not. Bromine water is dechlorized when shaken with the alkene because of the reaction happens, and the addition of bromine to an alkene can be carried out by using a solution of any halogen in organic solvent, such as, for example, we have the ethanol. So this is how that reaction happens, and the equation for that reaction will be, we have ethene like this one. This is the structural formula for this one, and whenever it undergoes addition reaction, or you can say that if a specific halogen like bromine is added, you call it also as the bromination. If chlorine is added, you call it as chlorination reactions. So what will happen whenever bromine is added to a ethene or any alkene, the bond will break between the bromine, and that bromine will act on the double bond that is present here. This is the pi bond. So the pi bond will break, and whenever the pi bond will break, two bromines are added, or they are attached with the carbon like this one. This will be the structure of bromine is present there and also there, plus you have two more hydrogen atoms that are present there. So this is the structure. Ethene react with the bromine and it produces 1,2-dibromoethane. So just like that, we can also do this with the propene and butene, anyone. So the product formed if the reaction is carried out with the bromine water is more complex. The bromine is still decolorized, but colorless product includes you can say that if a colorless product is included in the form of, like if we have CH2Br CH2OH. If OH group is present in this, and plus we have HBr, that is produce hydrogen hydrobromic acid. So this, in case of this addition product, 2-bromoethanol of the reaction between the ethene and the bromine water, this also happens. So whenever you add bromine in the ethene plus water is also added, so you're using the bromine water, not just a bromine gas, a bromine water. So the product produced is this one, and this colorless product includes OH group from the water that comes from this OH group. Hydroxyl group comes from the water because water has two types of ions, hydrogen ions, and water has hydroxyl ions. So hydroxyl ions attached to this one, and we have a colorless product that is produced in this reaction. So this is all about the addition reactions of the alkenes, and next we talk about the hydrogenation reactions of alkenes. So the hydrogenation reactions, as the name suggests, hydrogenation means hydrogen is added in these reactions. The name suggests that hydrogen is added. So this is also a type of the addition reactions, but specifically you do this with the hydrogen. So whenever hydrogen reacts with the alkenes, they form the alkanes. How they form the alkanes? For example, we have CH2 double bond CH2, which is the ethene. So whenever ethene reacts with the hydrogen in the presence of a catalyst, that is nickel, a specific catalyst is used in this. So the addition of hydrogen across a carbon-carbon double bond is known as hydrogenation, and ethene reacts with the hydrogen if the heated gases are passed over a nickel catalyst, and a specific temperature is also provided, like we have 150 to 300 degrees Celsius temperature is also provided. So whenever these conditions are fulfilled, the unsaturated the unsaturated reactant ethene will convert into a saturated product, which is the ethane. How? The hydrogen which we are adding in this, whatever it will undergo the addition reactions, and whenever it undergo the addition reactions, the double bond will break, and when the double bond will break, it forms hydrogen is added to these carbon atoms, and whenever these are added, that means CH3 single bond CH3. So this forms the ethane. So you can use any one. If you do it with the propene, then propene will produce propane. If you do it with the butene, then butene will produce butane. So you can use this hydrogenation reaction with any one for the conversion of that product into the alkanes. Other alkanes also react in a similar way, just to produce the saturated alkanes. So we have also hydrogenation reactions that are similar to the reaction with the ethene, as used in the manufacture of the margarine from the vegetable oils such as corn oil or sunflower oils. These are the edible oils, and they contain a long chain carboxylic acids. So hydrocarbon chains of these acids contain one or more carbon-carbon double bonds. So whenever you add the hydrogen, the double bond will break and the unsaturated molecules are converted into the saturated one. So for that purpose, as I talk about the vegetable oil, so whenever we have a vegetable oil in industries, these method is mostly used. For example, if you have a vegetable oil that reacts with the hydrogen, and whenever it passes over a catalyst, that is the nickel, and specific temperature is provided, and this reaction happens almost at about 60 degrees Celsius. So by hydrogenation, some but not all of the carbon-carbon double bond that are present in this vegetable oil in this, the liquid vegetable oil can be made into a solid but a spreadable fat. Means you can convert this vegetable oil into the margarine or a fat, because now the double bond is broken down into the single bond, so you can convert them into the margarine or the fat, that is the spreadable fat that we are using for this purpose. So this is the hydrogenation that happens, and this reaction, the last one, this mostly happens in the industries for the conversion of the vegetable oil into the margarine, fat, or also the ghee. So this is another important addition reaction, is the reaction that is used in the manufacturing of the ethanol. Ethanol is an important industrial chemical and is also a solvent. So it is the most important from the alcohols. It is formed when a mixture of steam and ethene is passed over a catalyst of phosphoric acid. Like if I wrote here, we have ethene, C2H4, that reacts with the steam, which is H2O, means in the gaseous form of the water. So we have a specific catalyst, that is phosphoric acid, and temperature, that is 300 degrees Celsius temperature. These conditions are necessary for some reactions, so you must have to provide these conditions. We have 6000 kilopascal is the pressure that is provided. So after that we have phosphoric acid, which is the catalyst which we add in this, and catalysts are just there to speed up the chemical reaction. So whenever you provide these conditions and the mixture of steam and ethene is passed over a catalyst, so at a temperature of 300 degrees Celsius and a pressure of 6000 kilopascal, the reaction produces ethanol of high purity that is needed in the industrial organic chemistry. How this will happen? We have, as This contains hydrogen. We have hydrogen and hydroxide that are present there. So what will happen in case of ethene? This is the structure of the ethene. So this hydrogen will act on the double bond and will break the double bond that is present in the carbon-carbon atoms. So whenever the double bond is broken, half is there, so half is there, hydrogen will attach with this one and hydroxide ions are attached with the other carbon. So this is how we have a product that is the ethanol, which is C2H5 and OH. So this is the ethanol that is formed here by the breaking of the double bond that is present in them. Hydrogen will break the double bond between the two carbon atoms and the reaction produces the ethanol. Other alkenes can be hydrated by the similar reactions. Just care is needed in identifying the product whenever when the carbon-carbon double bond is located at the end of the alkene molecule. So you can do this with the other series or other members of the alkene family. So all these are the reactions that happens in the alkene and the homologous series, and now we'll talk about the next one, which is the alcohols. So now we have the homologous series for the alcohols. Alcohol is a homologous series with a functional group that we have hydroxyl group. OH is the functional group for the alcohol, and the examples which are included in this, we have methanol, and the most important one is the ethanol, and next we have propanol, butanol. So all these are the examples that are included in the alcohols. So for the manufacturing of the alcohols, there are two methods that are used for this one, and those two methods are, first one is by the fermentation of the glucose you can get the alcohol. We will also discuss in detail the fermentation of the glucose that happens for the manufacturing of the ethanol. And the next method is hydration of ethene. This is also the catalytic addition of steam, which we have done here. This catalytic addition of steam is also known as hydration of ethene. Hydration, I wrote it here. So we have hydration of ethene. You can say that means hydrogen is added in the ethene. So whenever hydrogen is added in that ethene, you call it as the catalytic addition of the steam. So this is how through these two processes you can get the ethanol, specifically ethanol, which is an alcohol. So the next one is the catalytic addition of steam. So these are the two major methods, and we also discuss the pros and cons of these two methods which are used for the manufacturing of the ethanol. So first, as we have discussed the second one, so now we'll talk about the first one, which is the fermentation of the glucose. So the fermentation of the glucose, ethanol is prepared by this one, and the conditions for this are, we require a temperature which is 25 to 30 degrees Celsius. That is the temperature required for the manufacturing of ethanol by this fermentation process. And then we have a catalyst of yeast that is added in this. Yeast is used as a catalyst. And the third one is absence of oxygen. So this reaction happens in the absence of oxygen. So these three are the required conditions that are used for the fermentation of the glucose. This reaction will not occur at a temperature above 35 degrees Celsius. So you need 25 to 35 degrees Celsius is required. If temperature goes up 35 degrees Celsius, then the reaction will not happen, because the yeast that is present there get denatured because of increase in temperature. The yeast get denatured. Yeast will not work as a catalyst. Whenever it denatures, it will destroy. So that's why at a higher temperature this reaction will not happen. So the reaction equation for this one will be, we have a glucose, that is a required one. We use the glucose and provide the specific conditions, and the catalyst is also added, that is the yeast catalyst that we are using. A temperature of 25 to 30 degrees Celsius is required. So after that we have a product. The first one is the ethanol. With the ethanol you have carbon dioxide that is released in this one. So this is the word equation for this reaction or for the fermentation of the glucose. And now we talk about the symbol equation. The formula of glucose, which is C6H12 and then O6. So after reaction we have a ethanol. How ethanol is produced? You just have to extract the, or you can say that a carbon dioxide is removed from this one. So whenever you remove it, we have a 2 molecules of ethanol that is produced, C2H5OH plus 2 moles of carbon dioxide is released in this one. This is how the fermentation happens. This process is not continuous, so therefore it has to be done in the batch form. Once the reaction is completed, ethanol needs to be separated from the reaction mixture by the fractional distillation method. So the percentage yield of this reaction is approximately 15% yield is produced from this one, from the fermentation of the glucose. So we have 15% ethanol that is produced through this one. And the hydration of ethene, which is already done in the catalytic addition of the steam. So now we have some advantages and disadvantages, or pros and cons of the hydration and the fermentation. So we will talk about on. So these are the pros and cons of these two methods that are used for the manufacturing of the ethanol. The first one is by the catalytic hydration of the ethene. If we talk about the hydration of the ethene, the advantages which include is that this is a fast reaction. The rate of the reaction is fast, means it quickly proceeds. Second one is the most important one, that is it's a continuous process, and a high yield of pure ethanol is produced from the hydration process. But if we talk about the fermentation process, so in the fermentation we have this is a slow process. This is not continuous, and that need to be done in the batch form, and the less yield is produced in case of the fermentation process. As I already told about that, we have 15% yield of ethanol that is produced by the fermentation process. So these are the you can say that these three are the advantages that are of ethanol. And if we talk about the advantages of the fermentation process, is that it is done readily from the renewable energy source, and low energy consumption is provided, and it uses easily available materials that are provided, and it is relatively simple. A large vessel is required, and a simple or a straightforward process. So these three are this one, the first, second and third. These are the advantages of the fermentation, and these are the disadvantages. These three are the disadvantages of the fermentation process. So these are the disadvantages and the advantages of this one, of these two processes that we are using. So this is a comparison of the industrial methods for the ethanol production, and the disadvantages related to the catalytic hydration is we have to originate this from the non-renewable energy source, and the next one is a sophisticated and a complex method is required for this one. This is also the disadvantage, and a small scale equipment capable of withstanding the high pressure. So you have to provide a high pressure which is 6000 kilopascal. That is much higher. So that's why these are the comparison, or you can say that are disadvantages related to the ethanol by the hydration and the ethanol by the fermentation process. Now we'll talk about the uses of the ethanol. There are many uses of the ethanol, and some notable ones are as a fuel. We can use this as a fuel, and the second one as a solvent. It can dissolve a wide range of different substances, so that's why you can use it as a solvent. So if we talk about as a fuel, this is the combustion of the ethanol that is done. Ethanol combusts in the excess of air to produce the heat energy along with the carbon dioxide and also water vapors. So whenever ethanol is burned, we have the equation, which is, this is the ethanol, C2H5OH. Whenever it combust in the presence of excess supply of oxygen, we have carbon dioxide that is released, plus we have water vapors, and plus a lot of heat is also released in this process because it's a combustion reaction. Combustion reactions are exothermic reactions. A lot of heat energy is released in these reactions. So this is the structural formula for the ethanol, and the molecular formula for ethanol is C2H5 and OH. This is the molecular formula. So some countries also mix the ethanol with the petrol as a fuel. For some cars, it is also used for heating and cooking by using the domestic burners. If we have some domestic burners, so in some countries it is also used for the heating and the cooking purposes. So these are the uses. First one as a fuel, and then as a solvent. Also in case of the fuel, whenever we do the combustion of the ethanol in the presence of the excess of air, so the equation will be this one. We have a lot of energy that is released along with carbon dioxide and the water vapors, and the last one, it is also used for heating and cooking in our domestic purposes. Ethanol is basically a renewable energy source and has a potential to reduce the petroleum imports also. So with responsible development and the control, biofuels have potential to reduce the future environmental pollution, and the issue of sustainability must be considered too. So land is needed to grow the biofuel crops, so overuse of the biofuels could encourage unsustainable levels of the deforestation also. So now we'll talk about the last content of this chapter, which is the carboxylic acid and the esters. The carboxylic acids are another homologous series of the organic compounds, and these acids have the functional group which is COOH, and with the journal formula of which CnH2n plus 1, and then you have to add the functional group in this also. So this is general formula for the carboxylic acids. So when naming a carboxylic acid, remember that a carbon atom of the acid group is counted as the first carbon in this chain. So for example, if you have CH3COOH, then you also have to consider this carbon, and this is the first carbon for the naming purpose. That means the name of this one will be ethanoic acid, because the one member that contains the two carbon atoms, you call it as eth. So just because of it is a carboxylic acid, so you call it as ethanoic acid. That's why it is called as ethanoic acid, because there are two carbon atoms that are present in this molecule. You have to add the carbon atom of the acid group counted as the first carbon one, right? So this is the formula for the ethanoic acid, and the first most simpler one is the methanoic acid, which has just carbon atom with the functional group that is attached to it. If whenever there is we talk about the first carbon, so just or one carbon, you call it as a methanoic acid, and the second member of this one is the ethanoic acid, which is CH3 and COOH. The first two acids in this series are the liquid at room temperature, and ethanoic acid will also solidify if the temperature falls only slightly. So the acid dissolve in water to produce the solutions that are weakly acidic. And methanoic acid is present in the nettle stings and ant stings. So while ethanoic acid, once also called the acetic acid, is a well-known acid that is present in the vinegar. So these are the important uses of these one. So next we have more about the carboxylic acids. We will talk about the reactions that happens with the carboxylic acids. So the reactions that involve carboxylic acids are, first of all, the reaction is ethanoic acid plus a base. If you do the reaction, as this is a acid, so if you add the base in this, so what will happen? We have, even though the ethanoic acid is a weak acid, but it will react with the base to make a salt. But whether it's a weak or a, you can say that it's a strong acid, it will react with the base and form a salt. Like we have ethanoic acid, CH3COOH, and that reacts with any base, solution of any base, that is sodium hydroxide. So whenever they react, they form what will happen? The bond will break between the sodium hydroxide, and we have two ions that are present in the water, Na positive and OH negative ions. And if we talk about the ionization of the ethanoic acid or acetic acid in the water, then these ions are released: acetate ions and hydrogen ions. So as we already know that how the molecules attract each other, they basically depend upon the opposite charges that are present on them. So sodium will move towards the acetate ions and hydrogen will be attracted towards the hydroxide ions. So just like that, the products that are released here are CH3COO plus we have water that is released. So the name of this product is sodium ethanoate. You call it as sodium ethanoate, and this is the product that is formed when ethanoic acid reacts with the base. So the second reaction of these ones, whenever ethanoic acid reacts with the metal, first we talk about the base one, and now we have ethanoic acid with the metal. In the previous one, if you remember the preparation of the salts, the chapter related to the salts, how can you prepare the salts? We have three different reactions that involve: if acid and base react together, then a salt is produced; if acid and a metal react together, the salt is produced; and the third reaction is if acid and carbonate react together, then also the salt is produced. So you can use carboxylic acids in those reactions. So this is just like those same reactions. You can also check them from the previous one. So if ethanoic acid reacts with the metal, we have the formula, which is CH3COOH plus we have magnesium metal. As we already know that metals are the cations, they have positively charged, they have free electrons, they easily give those electrons or donate those electrons. So magnesium has the positive charge, and that magnesium will react with the acetate ions with this one and forms magnesium ethanoate. CH3, as magnesium will donate the two electrons, so what will happen to two acetate ions will react with one magnesium atom, and plus we have hydrogen gas that is released. So this is how the reaction of ethanoic acid and metal happens. So the third reaction of this one is the ethanoic acid plus the carbonate. For this reaction, what happened? We have to take some carbonate, and first we have ethanoic acid, which is CH3COOH plus you can take any carbonate, like we can take sodium carbonate and A2CO3. After reaction, what will happen? We have products that are released. We know that the general equation, whenever acid reacts with the carbonate, a salt, carbon dioxide and water is released. So we have carbon dioxide plus water that is released. With this one, a salt is produced, because we know that salt contains a metal and a non-metal that is present in the salt. So in that case, what will happen? We have acetate ion CH3COONA plus we have carbon dioxide and plus we have water that is released in this one. So these are the reactions how carboxylic acid reacts with the substances. So this is all about the reactions, and next now we will talk about the formation of the ethanoic acid by the oxidation ethanol. So how the formation happens? We have a bacterial oxidation to form the vinegar. Vinegar is the common name for the ethanoic acid, and ethanoic acid is the you can say that this is the scientific name or for the specific name for the ethanoic acid. So this is also known as acetic acid. The common name is the vinegar, and ethanoic acid is also known as the acetic acid because it contains CH3COOH that is present in it. So vinegar is manufactured by the oxidation of the alcohol. In this process, the bacteria in the solution oxidizes ethanol by using the oxygen from the air to produce the ethanoic acid. So the equation for reaction for this one will be, we have CH3 CH2 OH, we have ethanol, and that ethanol will react with the oxygen. So whenever it reacts with the oxygen, or when it is passed using the oxygen from the air, it produces ethanoic acid, which is CH3COOH, and plus we have a water molecule that is released with this one as a end product. So how this happens, we have this one, this from here, 2 hydrogen atoms are removed from this product, from this one, and those 2 hydrogen atoms will react with 1 oxygen to form the water, and that 1 oxygen and the other 1 oxygen is added to this one to form the ethanoic acid. So this we can also produce by using potassium manganate. So for that purpose, ethanol can be oxidized to the ethanoic acid by using aqueous solution of potassium manganate, and that potassium manganate is purple in color, but it loses its color when it reacts. So we have ethanol CH3, that is CH2OH, and whenever it reacts with the oxygen like this, now we have the monatomic one that we are taking for this reaction. Because it happens in the presence of this one, we have acetic acid that is released to COOH, and plus we have water that is released. So we can use, or we can add the acidified potassium manganate, which is also known as potassium permanganate or KMNO4. So in the presence of this one, this reaction will happen, and this reaction will happen, or you can say that the first of all, the potassium manganate is purple in color, but after the reaction it is colorless when it reacts. So the oxygen that is present in the square brackets, you can see here, this is the oxygen from the KMNO4 that we are using, right? So that's why it act as a oxidizing agent. That's why this reaction happens. And also one more thing, we are not using the oxygen from the air, we are using the oxygen from the KMNO4. The square brackets denote that oxygen is acting as a oxidizing agent. So this is the reactions or the formation of the ethanoic acid. And next, the last topic, which is about the esters. Esters are also the organic compounds that are made up whenever carboxylic acid reacts with the alcohol, and that reaction is basically known as the esterification. So in which reaction ester is formed, you call it as esterification reaction. And this is in this esterification reaction, we have ethanoic acid or any carboxylic acid can be taken. So whenever carboxylic acid reacts with the ethanol, which is C2H5OH, and in the presence of the sulfuric acid or acidified one, what will happen? We have so in the presence of sulfuric acid, it produces the product which is CH3COOC2H5. How this one is produced, how esters are produced? Hydroxide ions are released from the acetic acid, and hydrogen ion is released from this one. So whenever they are removed, they form a water molecule, and after the removal of the water molecule, the entire product react together and they form the esters. That ester is known as ethyl ethanoate, just because of the presence of this ethyl, or you can say that because it's a 2 carbon atom, so you call it as the ethyl, and ethanoate because 2 carbon atoms are present in this one, in this one. So this reaction is known as esterification. Esters usually have strong and sweet, pleasant smells, and they are used to make the perfume along with the food flavorings. So fat and oils are naturally occurring esters that we are using. So how can we name them? We can name the esters just it contains 2 parts. As we have done here, we will take the example of this one. We have CH3COOC2H5. There are 2 parts that are present. First we have this, and second is the other one. So it contains 2 parts. The first part of the name is the alcohol, and the second part of the name is the acid. first you have to do the name of the alcohol from which we are using. So this is the alcohol one. We are using the ethanol here. So we have ethyl ethanoate. This product is known as ethyl ethanoate. That means the alcohol that we are using is from the ethanol. So as we are using it from the ethanol, you call it as ethyl as a prefix. And the ethanoic acid that we are using, that gives the name of ethanoate because hydrogen is not present in it. So that's why you call it as ethyl ethanoate. So it contains two parts. The most important thing is first you give the name to the alcohol and then to the acid, carboxylic acid that we are using. So when writing the formula for the acid, we reverse this one, which means that in the formula we write the acid part first and then the alcohol part for this one. For writing the formula, you have to do the reverse, but for writing the name, you have to write the name of the alcohols and then for the acids, carboxylic acid that we are using. This is the most important thing about these esters. So now we are done with the esters also, and there are ethanoic acid, and we are done with the esters that we are using. This one, the reaction of a carboxylic acid with an alcohol produces an ester and a water. In the previous we talk about the carboxylic acids, and also before we talk about the alcohols, the homologous series of the alkanes, their reactions, their formation, and also about the alkenes. So this is all about today related to the chapter number 19, the reactions that are involved in the organic compounds. Hope you understand all this. If you have any question, you can ask in the comment box. If you like our content, then please subscribe our channel and share it with the others also. We will meet in the next one.